Have you ever wondered how the mean value theorem works in calculus? To put it simply, it's a fundamental concept that makes a very intriguing assertion. It states that for a given function that is continuous and differentiable within a certain interval, there is at least one point where the slope of the tangent line equals the average slope of the second line connecting the endpoints of the interval. Now imagine a function, let's call it fx, that is continuous in a closed interval from point A to point B and differentiable in the open interval between these points. The mean value theorem assures us that there is a point C in this open interval where the derivative of the function at point C equals the average rate of change of the function over the interval. To visualize this, consider the graph of the function fx within the closed interval from A to B. The second line, which connects the endpoints of this interval, intersects the graph at the points A and B. Now, somewhere within this interval, there will be a point C where the tangent line to the graph is parallel to the second line. The mean value theorem has a multitude of applications in calculus. For instance, it can be used to prove Rolle's theorem. This theorem states that if a function matches in value at the endpoints of a closed interval and is also continuous and differentiable within this interval, there will be a point within this interval where the derivative equals 0. The mean value theorem also helps to prove Cauchy's mean value theorem. This theorem states that if two functions, say f and g, are continuous on the closed interval from point A to point B and differentiable on the open interval between these points, there exists a point C in this open interval. To illustrate how to use the mean value theorem, let's take the function fx equals x squared. We need to find a point C within the interval from 1 to 2 where the slope of the tangent line equals the average slope of the secant line connecting the interval endpoints. Firstly, calculate the average slope of the second line, which equals 3. Then find the derivative of the function, which is 2 times x. This derivative represents the slope of the tangent line. To find point C, solve the equation where the derivative equals the average slope of the secant line. The solution to this equation is C equals 1.5. Therefore, the point C equals 1.5 is where the slope of the tangent line equals the average slope of the second line within this interval. To conclude, the mean value theorem is an indispensable instrument in calculus with numerous significant applications in mathematics, physics, and engineering. It is a theorem that all students of calculus should master.